I'm Anil Kumar, sharing with you some test questions on circle theorem. The question here is, in the figure below, AB of length 27 centimeter is divided in the ratio of 4:5 by the point E. If the length of CE is 5 times ED, find ED. You can pause the video, answer the question, and then look into my suggestions. Now here we have incorporated many concepts. One of them is circle theorem, the other one is concept of ratios. What we are given here is that the line AB is 27. So total length AB is equals to 27, and point E divided this line in the ratio of 4:5. So we'll say that AE is to EB is 4:5. Now, what are the lengths of AE and EB? How do we find it? So the trick involved here is that total length is given to us. 4 plus 5 is how much? Total becomes 9. Now what we have here is, if you compare the ratios, 9 times 3 is 27, right? So we are talking about ratio of 4:5. Total is 27. Now 9 times 3 is 27, correct? So that gives you directly the values of AE and EB. So if I multiply these by 3, I get 12 is to 15. Do you see that? So that is the fastest way of getting the solution and saves really a lot of time. So AE is 12 for you and EB is 15, right? So it doesn't look like that in the diagram. So don't really get confused with the diagrams given to you. They are never to the scale. So remember that part. And I've made it obvious, correct? So this looks to be longer, but it's much shorter. Okay. So that's the first part. We got, in very simple statement, the lengths of AE and EB. Now, another concept here is, how are length of these two chords related? If the length of C is 5 times ED, so CE is 5 times ED, we have to find ED. Now that's a difficult issue, right? How do we do that? Well, let's look into the circle concepts. Now if you see this arc BD, right? So for this arc, the angle A and angle C should be same, right? So what we see here is that these angles are equal because they have the same arc, right? So angles subtended by the same arc in a circle are always equal, right? And you know, vertically opposite angles are also equal. So we have two similar triangles. Do you see that? So we have similar triangles, right? So since these triangles are similar, their sides are in proportionate ratios, correct? So you can apply this concept of similar triangles, and from that we get that AE times EB is equal to CE times ED. Now this is a better way of writing rather than the ratios. I could have written ratios also, but this is better since it's a product, right? So in such cases, using similar triangles, we can say the product of these two segments is equal to the product of the other two segments of the chord. Now if we apply, we know already what AE and EB are, so placing their values, which is 12 and 15, let me write here. So we have 12 times 15 equals to CE. We can write CE in terms of ED. What did I write? CE times ED. CE times ED, sorry. So product of AE to EB is same as CE to ED, right? So this was ED. So I'll replace CE by 5ED. That is given to us. So 5 ED times ED, correct? So these are lengths we're talking about. So I'm not multiplying anything. Many tests you're not even allowed to have a calculator. So keep that in mind. So it is 5 times ED squared. Is it okay? And that is what we need to find. What is length of ED? So now you can write this as 12 times 15 divided by 5, right? That is ED square. So this can be simplified. 5 goes 3 times. And what you get here is 12 times 3, which is 36. ED square is 36. So square root of 36 is ED, right? Which you know is 6. We have to take only positive values since we are talking about lines, length, right? So we get our answer as ED equals to 6, which is option A. So that is how it could be solved. I'd like you to go through this video once again and refresh all the concepts you've learned about circle theorem, ratios, and similar triangles. Hope you find it interesting and useful. Feel free to share my videos, post comments, and if you like, that'd be great. Thank you and all the best.